This group is collecting, comparing temperature of the soil and the surrounding area. Morgan has an infrared thermometer where she can point at things and it'll tell them what the surface temp is. And Jamie has looks like a digital thermometer. He's going to stick in different, around the water and the ground and see what it is. And then Andrew has a fancy little computer that's going to tell us the temperature and dissolved oxygen, how much oxygen is in the water so the species can live and the fish can live, and to see how clean the water is. We'll come back and see that in a minute.
Okay, third graders. Today we're measuring 3 things in the water here in the Smoky Mountains. We're measuring the pH level. Now pH level goes from 0 to 14. Ideally we want the water to be right around 7. So we're going to measure and see about what the water is here. We're also going to measure the temperature of the water here. And then we're also going to measure something called the dissolved oxygen. Now dissolved oxygen means how much oxygen is actually in the water. Okay, let's watch this group right here. Walk out to the water. Now just like we want a lot of oxygen in the air, the fish want a lot of oxygen in the water. Most water has about 7 to 9% oxygen in it. If the water had about 20% oxygen in it, believe it or not, we could actually breathe in the water. So we're going to measure and see how much oxygen is actually in this water. When we get back to Birmingham, we'll compare the results that we get here to the results in the Cahaba River. We're also doing measurements in 3 different areas of this river. We're measuring in areas of the river that are stagnant. They're not moving at all, like right here. Then we're going to measure in slower moving areas, like about right there. And then the students will be taking measurements in fast moving areas, like you see way out there. So we'll have lots of measurements to go by when we get back. We'll share those results with you later.
You know, this isn't exactly precise with all the studies that we're doing here, but the temperatures basically said that the pooled water was 2.5 degrees. The slow moving water was 2.4 degrees. These are Celsius. And then the fast moving water was 3.5. Why would the faster water have a higher temperature?
It's moving more rapidly, therefore it has,
Possibly the moving, the energy, because remember when you're measuring temperature, what are you measuring? Energy in a particular object. Measure the soil or whatever it may be is the energy involved with it. So rushing water is going to have that temperature. Now, the dissolved oxygen was the main thing we're looking for. And the fast-moving water was 13.1 milligrams per liter, which means there's a certain amount of oxygen in that fast-moving water, which is about what we would be expecting. Why would there be more oxygen compared to the pool, which is 11.7 milligrams per liter? It's adding more air. How many of y'all have a fish tank? Anybody? What do you have to put in a fish tank to keep them alive for a long time?
filtering.
A filter and bubbles. That bubbles, you have to put air in water. If you have a fish tank that has no bubbles and it's just a tub of water, that fish can only live so long in it till it uses up all the oxygen. Just like being trapped in a steel vault for us. Eventually we'd use up all the oxygen. So the faster moving water, you're going to be able to see with the dissolved oxygen in there. So we're going to take these results, see how it compares to the Cahaba. Should be pretty close. And then the pH was pretty good. It was a 7.8 in the pooled water, which is that more acidic or more alkaline?
7.8 is more basic.
It's more basic or alkaline, so it's not acidic right here at all, which is good. The more acidic it is, the bad and more dangerous it is. The slow water was 7.9, and then the fast-moving water was an 8. Okay. Now, why that is, I'm not 100% sure. Any ideas? While the faster water would have a higher pH?
Yeah, and that's actually contrary to what you generally find as well if your rivers tend to be more acidic.
Could be
Really?
user error.
I don't know. Maybe it could be user error. It could be just this probe. But this morning was the same result for some reason. That's why I'm looking like it shouldn't be that way, but it is. So anyway, and soil temperature is exactly 0 degrees Celsius, 32. So anyway, we'll take these results. We'll see what it compares to the Cahaba, and then we'll see when she takes you on this to see how any of these results would or should affect the animals living in here.
Well, we are turning over rocks looking for insects underneath the rocks because the insects will tell us if the stream is healthy or not based on the type we find and the number that we find.
Okay.
And so here we have some, and we're looking on this rock here, and we have some tiny little creatures, and they're actually not ants, they are larvae. These are stonefly and mayfly larvae, and this one looks like...
And would you explain to the third grade what a larva is?
Okay, well, when... that's good for now. Insects go through something called metamorphosis, and so they start out as eggs, and as they grow they change, sort of like how a butterfly changes into, or a caterpillar changes into a butterfly. And so one of those intermediate stages is the larva stage. And that's what we're looking at right now.
Come on, Story. We're the third grade's here. Story, what'd you find?
Oh, this is a good one.
I'm not sure what it is.
This is another one of the larvae, and this is cold. You can tell the species by the number of tails, and this one looks like it only has looks like 2 tails, so that might be a stonefly.
Okay. Oh, there's another one right there.
Oh, there's another good one. Okay.
If we look, we can see, if I can zoom in before you take him off, if y'all can see third grade, there's the tail. He's moving, he's alive.
Yeah.
It's a tail?
Yeah. Story, how cold was the water?
Pretty freezing.
The
rock's colder.
All right.
Yeah, the water's probably about 40 degrees.
40 degrees.
Maybe a little less.
So you can see, third grade, what we've collected, they're in here, the small ones that are in here, we've collected from here at another site. And we'll go up and look at them in a minute in a microscope, and then we'll bring them back and put them back where we found them.